Okay, so today we're going to build on our knowledge of trig that we've been doing the past couple weeks, and we're going to apply it to right triangles. So we're going to be doing a little bit with Pythagorean theorem like you've learned before, but then we're also going to be using sine, cosine, tangent, cosecant, secant, and cotangent to find some missing lengths as well. So this lesson has a bunch of different examples in it. First off, you need to know what the Pythagorean theorem is. This is used for right triangles only. So we get into some problems when we can't find side lengths when they aren't right triangles. So here's the Pythagorean theorem. My guess is that you probably haven't forgotten it because you use it a lot in pre-algebra and algebra 1 and geometry. So a squared plus b squared equals c squared, again, only can be used for right triangles. So that's how we find some missing side lengths, and we're going to be doing some practice with that. Okay, so for this one, first example, it says find the missing side length. So we've got 8 and 4, and what we don't know is the hypotenuse, which is opposite of the right angle. So we're just going to say that this is A, this is B, and C is what we don't know. Okay, so we've got to plug in. So A squared plus B squared equals C squared. So I need to plug in 8 squared plus 4 squared equals C squared. Okay, 8 squared is 64. 4 squared is 16. And C squared is what we don't know. All right, and then 64 plus 16 is 80. And we need to take the square root of that. And if you type the square root of 80 into your calculator, it is going to come out as a decimal, which we don't really want, so we're just going to leave it as a square root of 80. Other years when we have more time, I usually have you guys break that down. We really don't have time for that, so I am just going to leave it at the square root of 80. So that is the missing side length. Okay, next one. Find the missing side length again. This is a right triangle again, so we're good there. We'll say that this is A, this is B, and this is C. Remember that C is always opposite of the right angle. So we can't say that that other side is C. C is always given. A and B, they don't really matter. Okay, so same formula. We've got 3.6 squared plus B squared equals 7.4 squared. Okay, and I do not know these numbers off the top of my head, so I'm going to have to use the calculator. So 3.6 squared is 12.96, and 7.4 squared is 54.76. Okay, now we've got to do a little bit of solving here because we need to get b by itself. So subtract b squared equals 41.8. And then we need to take the square root. So b equals square root of 41.8. Just make sure that that doesn't reduce. Nope. So we're just going to leave it at that. For Math Excel, since these were already written in decimals, they might want the decimal approximation, which would be 6.5. Okay. Next one, these are the right triangle trig identities. You might have heard of SOHCAHTOA before. That's the abbreviation. So SOH, CAH, and TOA. So you're going to want to write these down. We've been over the opposites of each of those before when we were talking about the other trig that we were doing, but you need to know those as well because now we're going to be moving on and it's going to want us to find the 6 trig identities that go along with the triangle that we were given. So sine is opposite over hypotenuse. And every time we're talking about opposite, adjacent, we're talking about the angle or the side length that we're dealing with. Okay, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the opposite of sine, that is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. You're going to want to pause this if you didn't have enough time to write that down. Okay, it says find the 6 trig identities for the following triangle. So our theta is here in this bottom corner, so that's what we're going to be using as our measure for opposite and adjacent. Okay, so the first one we're going to find is sine of theta. So sine is opposite, so that's here, opposite over the hypotenuse, which is 4 square roots of 5. Okay, now we've been over this before. We cannot have a square root in the denominator, and we can also do some simplifying here. What does 8 over 4 reduce to be? Okay, 2. And then we have to rationalize this, so we have to multiply. So that's 2 square roots of 5 over, this is the square root of 25, which is 5. So sine is 2 square roots of 5 over 5. Okay, let's go ahead and do cosecant, since that's the opposite. So that would be 4 square roots of 5 over 8. These two would reduce to be 1 over 2. So sine and cosecant are done. I'm going to erase this red here. Oops. Okay, let's do cosine. Cosine is adjacent over hypotenuse, so that would mean this angle. So 4 over 4 square roots of 5. Okay, 4 over 4, that reduces to be 1. Then we've got to rationalize it here. Multiply square root of 5 over 5. And the opposite of cosine is secant. So that would be 4 square roots of 5 over 4. So I'm just flipping that beginning one. 4 over 4 reduces to 1. So it's just square root of 5. Okay, erase my green mark here. And the last one I'm going to do is tangent and cotangent. Tangent is opposite over adjacent, so opposite over adjacent. So 8 over 4, which is 2. And then cotangent would be 4 over 8, which is 1/2. So that is how you find the 6 trig identities based on a triangle. Okay, last one. We have the triangle with sides 12 and 5. What we don't know is this side here, and that's a problem. So just like that last one that we did, we have to have our hypotenuse in order to find the 6 trig functions. So first thing we need to do is that. So 5 squared plus 12 squared equals c squared. Okay, 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. And square root, that is 13. So this side here, I'm going to fill that in, is 13. Now I can go ahead and start finding my trig identities. So I'm going to start with sine. Sine is opposite over hypotenuse, so opposite would be 5 over 13. Make sure we can't reduce that. We cannot, so that's in lowest terms. The opposite of sine is cosecant, so that would be 13 over 5. We cannot reduce that either, so that is done. Next one we're going to do is cosine. Cosine is adjacent over hypotenuse, so that would be 12 over 13. That's already in lowest terms, so we're good there. Secant is the opposite of cosine, so 13 over 12. And the last one we have is tangent, which would be opposite over adjacent, so 5 over 12. That doesn't reduce. And cotangent is the opposite of tangent, so 12 over 5. All right, your work is on Google Classroom.